important to know about. So what is hypothesis testing? Well, this is the way scientific, discovery happens. This is the way products are tested. We collect data from a sample. We do some sort of evaluation of the data, and then we try to make a decision as to whether or not there is sufficient evidence based on this analysis of the data to reject some sort of research idea or thing that we're testing, and that's called the null hypothesis. I'm going to go through just the main points of this chapter. There's basically 3 tests we're doing: a z-test, a t-test, and a proportion test. Part of doing these tests is that there are 5 steps. Okay, so this is the basics. I like these 5 steps. This is what I always teach. The first step of hypothesis testing is to develop this null and alternative hypothesis, and I'll talk more about that in a minute. The second step is we specify a level of significance. You might remember this from Chapter 8 in confidence intervals. The alpha is the difference 1 minus the confidence level. It's the things in the tail. Basically, this is given to you in a problem, so you don't have to sweat it. Step 3, we're going to collect some sample data, and we're going to compute the value of the test statistic. Ooh, that was hard. Either the z-score or the t-score. Then we're going to use that test statistic and compute something called the p-value. This is new. Well, relatively new. It's basically the probability of getting that test statistic if your null hypothesis is true, and I'll go over that more. And then we're going to reject the null, which is basically HO. That's our convention for the null hypothesis. If we get a p-value that is less than our alpha, if it's unlikely to have gotten that test statistic given that our idea, our null, is true. I know it seems weird. Let's go through it. Remember, we're just going to be statisticians and do the process. Okay, first let's talk about what is the null and what is the alternative. Okay, so the null hypothesis, we call it H0 or H0. It's an assumption about the population that we're going to try to test. And then the alternate is always called HA, and that's the alternate hypothesis, and it's the opposite. So these 2 things have to be mutually exclusive. So then you might wonder, how do we set this up? It isn't always easy. It's a word problem, and you put the word problem into this format. So let's just try this a little bit. So this is developing the null and the alternative. Sometimes what's happening is you're trying to test a research hypothesis. You have some sort of idea. Let me tell you, the convention is if you're trying to test an idea, you put that into the alternative. So maybe the example is a new Salesforce bonus plan is developed in an attempt to increase sales. So then what's our alternative hypothesis in words, and we're going to put it into numbers later, is that the new bonus plan increases sales. That's our research idea. We put that into the alternative. And then once we know our alternative, we back into the null, make it mutually exclusive, and it's that it will not increase sales. That would be our null. Okay, here's another one. Sometimes, rather than a research idea, we're trying to challenge an assumption. When that happens, oftentimes, we'll put it into the null itself. So let's say an example is the label on a soft drink bottle states that it contains 67.6 fluid ounces. So maybe we put into the null, the label's correct, and then we put into the alternative, the label is incorrect. And you can see now we're starting to use some of this less than and greater than or equal to. The mu here is the population parameter. That's what we're testing. The equal sign, by the way, will always go in the null. So here are some examples of what it can look like. So these are the summary forms. Here, let me move this a bit so you guys can see the, oops, there we go, 2-tailed, yikes. Sorry, everybody. So you can have 3 different types of hypothesis that we're testing. One where you've got the alternative is less than, and we call that a 1-tailed test because it doesn't have an equal sign in the alternative, and it's going to be a lower-tailed or left-tailed test because this is pointing to the left. We can have an upper-tailed test. What that means is that we're going to have the rejection region be where the mu is greater than what we're looking at. And then here's a 2-tailed test. It's when you say they're either equal in the null or not equal in the alternative. The not equal always goes in the 2-tailed. Okay, let's keep going. So what is a p-value? How do we do this kind of p-value part that tells us if we're rejecting or not? As I said, it's the probability that we're going to get the test statistic that we calculate, the t or the z-score. And if it's pretty high, that means that our null must have been true. It's likely that we got that z or t score, that test statistic, with our true null. If it's low, then that means not likely to have gotten that from the sample data. given that our null is true. So here is the rule for hypothesis testing. You are going to reject the null if the p-value is less than or equal to the alpha. Remember, the alpha is given. The p-value is going to be calculated by your calculator. Okay, let's go through an example. So I've got some calculator things here. Let's read the example first. So the response time for a random sample of 40 medical emergencies were tabulated. The sample mean is 13.25 minutes. The population standard deviation is believed to be 3.2 minutes. So we want to perform a hypothesis test with the significance level of 0.05. There's our alpha. And we're going to determine whether the service goal of 12 minutes or less is being achieved. Okay, so this is going to help us formulate our hypothesis. By the way, if we know our population standard deviation, see I've got standard deviation known here, we're going to use a z-score. By the way, also what we're going to do, let me see if I can get this over here a bit more, is we're going to use the calculator and we're going to go to stat, test, we're going to choose one for z-test. This is not interval, it's a z-test. We're going to arrow over to stats, and then we're just going to input this data. Input the mean, the standard deviation, the sample mean. Oops, I spelled sample size wrong. We're going to choose the tail, left-tailed, right-tailed, or two-tailed, and it'll do it for us. Here's what the 5 steps look like, though. We've got to develop the hypothesis. Our alternative is that it's greater than 12. That's what we're testing, right? We want it to be less than or equal to. So there's our null, less than or equal to the 12 minutes. Step 2, our alpha, given 0.05. Step 3, calculate that test statistic. That's just our z-scores that we did. X minus mu over standard error, we get 2.47. By the way, we'll get that on our calculator. If you do those commands that I told you, basically these 5 steps is what your calculator is doing for you. We get a p-value that pops out of 0.0068. That comes from your calculator. By the way, that's pretty small, right? It's less than our alpha of 0.05. So we are going to reject. That's our rule. So what does it mean? There's sufficient statistical evidence to infer that Metro EMS is not meeting the response goal of 12 minutes, right? That was our null. There we go. There is our null, less than or equal to 12 minutes, and we got such a low alpha, we had to reject that. That's how these work. Okay, let's keep going. Let me tell you a little bit about what a type 1 error is, just so you know. It's if you reject the null when it's true, and that's basically the level of significance. You could have a type 2 error where that's accepting the null when it's false. So we don't always get things right. We try to avoid making this type 2 by saying things that, rather than saying that we accept the null, we say we do not reject the null. That's how we try to address this. These are some conventions. Okay, let's try a two-tailed test. So what that means is you're going to have an equals and a not equals. So let's say glow line for toothpaste is designed to fill tubes with a mean weight of 6 ounces. We take a sample of 30 tubes and we want to check for quality assurance procedures that we are having the sample results consistent with the assumption that the mean filling weight for the population of toothpaste is 6 ounces. Okay, so there's a lot here. How do we put this into a null and an alternative? We have a sample of 30 toothpastes. Let's say the mean of the sample is 6.1 and the population standard deviation is believed to be 0.2. So again, we're going to use a z. Let's do a hypothesis test at the significance level of 0.03. So let's go through our steps. Here we're going to set up our alternative hypothesis. The mean does not equal 6. Remember, we're comparing it to the population. The null is our mean equals 6. It's a two-tailed because it's not pointing in one direction or another. Oops, let's get this better. Our alpha was given. We can create a z-score, x minus mu. We plug in 6.1, that's our x bar from our sample, minus our population mean over our standard error, right? The n was 30, and we get a z-score of 2.74. What's the p-value, the probability of getting that? 0.0062. So 0.0062 is less than or equal to our alpha. So again, we reject the null. So it's the same 5 steps, it's just a slightly different process. You're going to go to the same stat, test, z-test, and plug in all the stuff. All right, let's keep going. Let's do it for a t-test. The only difference here is that we don't have a standard deviation for the population that's known. So remember, for t, we use s, which is the sample standard deviation. And we're going to need to know the degrees of freedom, which is n minus 1. We're going to get to use our calculator like before, except we go to stat, tests, and choose 2, which is t-test. Going to enter the same information. All right, so if we do this, let's read through this here. Let's do an example. Highway patrol, this is a one-tailed test with the standard deviation of the population not known. So let me read this for you. Sorry, everybody. All right, state highway patrol periodically samples vehicle speeds at various locations on a particular roadway. The sample of vehicle speeds used to test the hypothesis. Okay, so we're going to have a null of the mean of the samples being less than or equal to 65. So we're going to go through this and we're going to try to figure out, here's a sample size of 64 vehicles, and we get that their mean speed is 66.2. And we have a sample standard deviation of 4.2 miles per hour. So let's use an alpha of 0.05 and do some sort of hypothesis test. Let's go through the steps. We're saying we're testing to see if they're not greater, so we're putting that research test into our alternative. Mu is greater than 65. Null is mutually exclusive, less than or equal to 65. We're doing a right-tailed test because the alternative is pointing to the right. With the significance levels given, 0.05, we can compute our t-score. We get a 2.286. Again, calculator will do that for you with the commands that I showed you. Pops out a p-value. The p-value is going to be in the range here. You'll see what comes out of your calculator, but no matter what, it's less than our alpha of 0.05. So what do we do, guys? We reject. We reject this null. So we can say it in a different way. You know, knowing that the significance level is 0.05, we can go back to that idea of confidence, and we can say that we're at least 95% confident that the mean speed of vehicles at location F is actually greater. We are rejecting the null. You could say it as rejecting the null, or say it this way. All right. One more test I need to tell you about, and that's a population proportion. Okay, so there's a slightly different z-score calculation for this. This is something we've gone over. Your calculator will do it for you. It's a different test statistic. You take the average proportion, right? This isn't a raw number anymore. It's a percentage from the sample, subtract the proportion from the population, and you divide it by the standard error of the proportion. Remember this formula here? And there's some conditions we have to meet. I'm not going to ask you to memorize those. They're in your textbook as well. Calculator is going to help us, guys. We're going to go to use calculator to do this. Go to stat, test, go down to one proportion z-test, not interval. I think it's number 5 on your calculator, and enter in the data. All right, so I've got that on the next thing. Here's a problem. Let's say that we've got this National Safety Council and that they are estimating 500 people will be killed, yikes, and 25,000 injured on the nation's road on Christmas and New Year's. They claim 50% of the accidents would be caused by drunk driving. So here's the percent. We're going to do a proportion. Here's our sample. 120 accidents show that 67 were caused by drunk drivers. So we're going to go ahead and test this at an alpha of 0.05. Where do you go? You go to stat, test, choose 5, one proportion z-test, enter the data. Okay, so it's going to ask you for your population proportion, that's 0.05. It's going to ask you for your x value, that's the sample proportion, so 67. Your calculator wants it in raw numbers, not percentages. N is 120, and then you're going to select a two-tailed test because you'll see on the next slide that that's what we're asking. We're asking if it's greater than or equal to that. So here we go. We've got a null of proportion equals 0.5. The alternative equals not equal to 0.5. We're given our alpha level. Here's the way we'd calculate by hand what our test statistic is. There it is, 1.28. You'll get that from your calculator. Then we need to know what is the proportion. Okay, and here's what comes out. By the way, I'm going to get rid of that. You don't need to know about that. So the proportion is for 1.28 when you do a p-value score that's two-tailed, 0.2006. That's pretty darn high. Do you guys see that's a large p-value? So the probability of getting that test statistic is high if our null's true. So that means we cannot reject the null, and that's what we find. All right, that's hypothesis testing in a nutshell. Good luck. Be in touch with me. Please ask questions. All right, bye everybody.